Okay, sorry guys, I had to interrupt there. Somebody came to my door there as I was getting ready to start problem number 3. I'm back. So pick up there on problem 3 real quick. So let's take problem 3. Okay, we have chromium 51 has 128-day shelf life. Okay, so I'm guessing nobody got this one right because Brainiac me forgot a decimal point here. Okay, so you either had a really big giant answer if you did that at 5, you should have had 32,000 something, whatever, but I'm still going to work it, but it should be 5.1 grams, okay? All right, if 28 days is the half-life, after 168 days ago, so I'm working it backwards, so instead of dividing, I'm timesing. Aha. So if 510 is where I'm at, it wants to know where I'll be if this is after 6 half-lives, 5, 4, 3, 2, and 1, okay, and then back to the original, all right, so after I do this, so I'm going to basically take, if I do this correct, all right, 5.1 times 2, 10.2, times 2, 20.4, times 2, 40.8, times 2, 81.6 times 2, 163, make sure I'm doing this right, 163.2, and then back to where it was after that 1 half-life, which would be right here, times 2, should be 326.4 grams, okay? So what I did there, guys and gals, is it said, and this is once again problem-solving skills, all right? And I guarantee, obviously, you would have got 32,640 if you would have done it the right way at 510. But that's my fault. Obviously, should have been 5.1. So if you did it at 510, your answer you would have put in was 32,640 grams. But what it was saying is, it was really easy to divide this into this and get 6 half-lives, okay? So it said after I had, this was my sample after this time frame. So they wanted to go flashback, okay, so what was it before that 168 or that 6 half-lives? So remember, if I was here, 5, so I times it by 2, 4, 3, 2, 1, and then back to the original, okay, because that's where I messed up because I'm sitting in 6, because this would have been half, that's what you see if I'd have happened. 6 half-lives, 1, 2, 3, 4, 5, 6, that's where I would have got 5.1, like I said, no. So that's where I would have got the 5.1 grams, which was here, guys and gals. Okay, so that was number 3, okay? All right, sorry about that. That's my mistake, all right? So the only way we get this stuff, like I said, is by practicing it, all right? So now I'm going to do number 4. I'm going to just scoot up my bar here so it moves up closer on the screen. Okay, number 4. Let's see, where did I put marker? Okay, number 4. Okay, this one's in time, okay? So if I had a 20 gram of radioactive, 20 grams of radioactive isotope present at 1 p.m., okay, great. And at 5 grams remain at 2 p.m. So that is a whopping 1 hour later. So what is the half-life of this isotope? Okay, so number 4, if I have a 20 gram sample, 20 gram sample, okay, of radioactive isotope are present, okay, at 1 p.m., right? Then, and 5 grams remain, okay, at 2 p.m., all right? What is the half-life of that? So 1 hour later, how'd they get to 5 grams? Well, if this is what I was at and I had an hour time frame, how did I get to 5 grams? Well, let's think about it. Well, half-life's half, so let's just make it simple, all right? So I halved it and got to 10, then I halved it and got to 5. So if there's a 1 hour difference here, this is at 1 p.m., and this is where it was at 2 p.m., doesn't that make that 30 minutes and 30 minutes? Oh, so this half-life of this isotope must be minutes. So sometimes these are like little trivia questions. You have to think about it, little brain teaser questions, okay? Make you think a little bit, all right? So the answer there was 30 minutes because I had 20 grams, and an hour later I was at 5 grams, and want to know how long was the isotope, so I had a 1 hour total, okay? And it halved, and how to get to that took 2 times, so I could just divide 2 into 60 minutes would have gave me 30 minutes, right? Okay, there you go, all right? So that is number 4, all right? So number 5, the half-life of uranium-238 space modulator. Notice I'm talking about Marvin the Martian because you remember Marvin the Martian, if you're a Bugs Bunny Looney Tunes fan, Marvin the Martian was always trying to blow up the Earth with uranium-238 space modulator. Him and Bugs Bunny, you remember that? Okay, look it up. Okay, he's the little guy with the little Roman hat and the blacked out face and the little, he had the little tiny guy who talked like this. Yeah, okay. All right, anyway. All right, so half-life 238 is 4.6, so this is a very slow deteriorating, okay, isotope. And the age of Earth is 4.6 billion years old. Okay, what percentage of uranium-238 that was present when Earth was formed still remains? Well, okay, so if 238, half-life of 238 is 4.6 billion years, and the age of Earth is 4.6 billion years, what percentage of uranium-238 still remains? This is number 5. So think about it. If I started with 4.6, okay, and we know that exactly 4.6 later, because that's how old the Earth is, so from day 1 to 4.6, all right, this thing would have halved, right? All right, so if that's its shelf life, then wouldn't it be safe to say that uranium-238 that was present when the Earth was formed still remains would be 50% because it's halved one time, right? So wouldn't that be right? So if the Earth is 4.6 and uranium is 4.6 and 4.6 and 4.6, so that means it's gone through one cycle. So if I had 100% at one point and 4.6 billion years later, it's halved one time, that leaves me 50%. So a little simple brain question, a little 50% action. So not much figuring there, just making you think a little bit, all right? So that'd be 50%, all right? 50%. Okay. Okay. So that's number 5. All right, so number 6, and then I'll stop at that, and I'm going to break them up into 2 videos. All right, number 6. Chromium-48 decays after 3 half-lives. What percentage of the original nuclei remains? So I'm looking for a percent. Asking for a percent. So chromium-48 decays after 3 half-lives. Okay? All right. So 3 half-lives, what percentage is left? Chromium 3 half-lives will be this, times this, times this. 2 times 2 is 4, times 2 is 8, so that'd be 1/8 portion, okay? Or if I divide 8 into that, my percentage is going to be, for number 6, 12 point, is it 12.6, 12.5? 12.5. 12.5%, okay? So 1/8 is the same as 12.5 if you figure out what percentage is that out of 100, or the pie graph. So if I did this, there's 1, 2 half-lives, 3 half-lives. So 3 half-lives that, so this is 1/8 or 12.5% of the entire original mass. All right, so number 6 is 12.5, okay? All right, moving along. Doing good. All right, checking your answers. And you're probably some of you are going, oh man, I just got to learn to not rely on Googling everything, that just what is the question asking? And you're like, gosh, if Myers says that one more time, I think I'm going to get nauseous. All right, I gotta do that, 7. Go ahead and do, oh God, I'll tell you what, let's just go ahead and finish it off. So number 7. So the half-life of iodine-125 is 60 days. About how much of a 144-gram sample would remain after 1 year? Okay, so this is where you gotta go, wait a minute, there's 365 days in a year, right? So I'm gonna divide 60 days into 365, okay? And so I have the right math. 365 divided by 60. Oh, come on, computer. Left me to a 6, so that is 6 half-lives. 6 half-lives. Okay, let me fix my cable here. Okay, so don't do it again. So because 60 days, 1 year is 365. So when I divided this and that, it came out to be 6. So basically, it wants to know if I got a 144 gram sample. Wants to know how much after 1 year. Well, I got to divide this 6 times. 1, 2, 3, 4, 5, and 6. So 144 divided by 2. All right, after 1, it's 72. Divided by 2 is 36. That's 2 half-lives. Divided by 2, 3 half-lives. I got 18 left. Divided by 2, that's 9 after 4. Divided by 2, that's 4.5. And the last but not least, after 6 half-lives divided by 2 is 2.25 grams. Okay? 2.25 grams is number 7. 2.25 grams. Okay? All right, moving along. The reason I can go fast is because you can watch these videos back and forth and stop, work them out, see how I did it, not having me to drag them out really long. All right, number 8, titanium, space shuttle stuff here, decays with a half-life of 6 minutes. How many minutes will it take for a 400 gram sample of titanium to decay down to 15 grams? All right, well, let's just do this. 480, and I'm just going to, all right, so let's just take our 480 divided by 2. That's 1 half-life, so 240. That's after 1. Divided by 2, that's 120. That's 2 half-lives. Divided by 2, that's 60. That's 3 half-lives. Divided by 2, that's 4 half-lives. We're down to 30. And I'm wanting to go all the way to 15. Oh, look, what's next? Divided by 2, down to 15. That's 5 half-lives. That's the number I was looking for right there, 15 grams. So, if 6 minutes is how long each one of these took, we'll shoot. 1, 2, 3, 4, 5. 5 times 6, 30 minutes. 30 minutes. Okay, pretty fast. So in order for this sample to go from 480 grams to 15 grams at a 6-minute half-life, did it 5 times. 5 times 6 is 30 minutes. Okay? And that was number 8. Okay, number 9. All right, number 9. Okay, a medical institute requests 1 gram of bismuth 214, which has a half-life of 20 minutes. How many grams of bismuth 214 must be prepared if the shipping time is 2 hours? Oh, that's a good one. This makes you really think hard here. Okay, so I am requesting a 20, how much? Oh, I need 1 gram. I need 1 gram of bismuth. Okay? And if it takes 20 minutes for a decay, so and it's a 2-hour shipping window until I get that 1 window. So obviously, if it goes through 20 minutes, okay, is a window, and 2 hour shipping, well, looks like there's 3 half-lives per minute, right? 20 times 3 is 1 hour. 20, 20, and 20 is 60 minutes. So it looks like I'm going to go through 6 half-lives with this bismuth. So I got to figure out how much do I send so when it gets there in 2 hours, I got at least 1 gram? Okay, so let's just do this. Okay, let's work it backwards. All right, if I need 6 half-lives and I need 1 to start with, okay, I need that ended up at the end of 6. So at the end of 6 half-lives, I need 1. So 5, 4, 3, 2, 1. Okay, 5, 4, 3, 2, 1. All right, so 1. After that is I'm going to times it by, or double it, times it by 2. So obviously 1 times 2 is going to make it 2. And then, so I got 2. So then I want to do it again, times 2. So now after 4 half-lives, it's going to give me 4 grams. Okay, times 2 is going to give me 8 at 3. Times 2 is going to give me 16. Okay, and then times 2 is going to give me 32 after 1 half-life. So then that means that's when it first starts decaying. So before I get to that, I got to go back to the original. So that means I need 64. Because just do the reverse math. If I started out with 64 and I need 1, and I got a 2-hour shelf life window, 20 minutes, 20 minutes, 20 minutes, there's 1 hour. Another 20, 20 and 20, there's another hour. There's my 2 hours, okay? So when it gets there in 2 hours, I'm gonna have 1 gram. So my answer, I need to ship 64 grams of bismuth, 64 grams of bismuth to wherever it is, this medical institute. So when it gets there in 2 hours, they'll have at least 1 gram to work with. Does that make sense? I hope so. Okay? All right? All right. Last one. Last one. Number 10. Number 10. 10. 10. The favorite one, 10. All right. Okay. So the half-life of radium-226, okay, is 1602. If you have 500 grams of radium, 500 grams of radium, how many grams would be present years ago at 32? Okay, so I got to do that backwards. This is like that problem where I had to go, where I got to on number 3, 326.4 grams. So it wants to know, so basically 1602 is 2 half-life. You times this times 2, that gets that. So basically I'm going through 2 half-lives, okay? So if I have 500 grams today, it wants to know, if I go back in time, what was this, okay, before 2 things before. So this is after 2, after 1, and then the sample. So that would be, times 2 would be 1,000, right? And then what I originally started with before I started half-lifing. So it would be 2,000 grams. All right, check my math. Think about it. If I have 2,000 grams, halve it, goes to 1,000. That was after 1,602 years. And then it halved again after another 1,600. So that made a total of 3,204. That gives me my present sample of 500 grams, like I said today. That is the same time frame. So the sample had to be 2,000 grams back 3,204 years ago. Okay? So that's 1 through 10. All right, I'm going to take a break, and then I will also walk you through problems 1 through 6 that you're submitting. That way you can see the work, you can practice, you can see your mistakes, and all that good stuff. Okay? All right. Boom. That's a wrap. Superman.